हाँ चलो चालू, थोड़ा सा ऊपर करो, कर दो चालू। हाँ बस सही है, सही है, सही है। हाँ चालू।
So today's topic is X-ray production. This is your X-ray tube. This is the X-ray tube having cathode and anode. Two parts. So in case of X-ray production, some input is given and we take the output. And this output is from the X-ray tube itself. And the efficiency of this tube is very less. We call it inefficient tube because this tube will give you only 1% X-ray. What is left? 99%, that is the heat. So we have multiple mechanisms or ways to remove this heat. But the result of this tube, where we give 100% our input and what we are getting 1% X-ray. So this is the poor efficiency of our X-ray tube. This X-ray tube, as we saw in last lecture, it consists of two parts like your cathode, anode, and both are made up of tungsten metal. So if we start with the X-ray production, there is one line you find in every book that X-rays are produced when high velocity or high speed electron strike metal. So from this line, the X-ray production is started. What does it mean? X-rays means 1% X-ray and 99% is heat. X-rays are produced when high-speed electrons they strike the metal. So what is the metal? We have anode. High speed. What is the meaning of this high speed? High speed is because of your kVp, because of your potential difference, voltage difference. What is electron? The source of this electron are the filament. So the filament is the source of electron. So we start with the source of electron, then we'll apply potential difference, make them high speed electron, then they will strike the anode and the result will be production of this term X-ray. So if we start with filament, in case of your X-ray tube, there is one filament and this is the cathode portion. This filament is similar to our bulb. In case of our bulb, we have filament. This filament is similar to that filament which we use in our electric rod. So this is your electric rod which you use in case of winter to boil or warm the water. So this filament and this bulb filament and this filament of cathode, all these three filaments, they work on the same principle. What is that principle? In case of bulb, in case of electric rod, when we switch on, means what we are giving to these structures, we are giving the electric current. We are giving electric current. That electric current will heat your rod, electric rod, and because of that heating, your water becomes boiled or heated up. So this mechanism is following in case of electric rod bulb. The same mechanism is occurring in case of this cathode filament also. From outside, what we are giving MA. Ampere is the SI unit of current, and milli means the current is small in amount. So we are giving milliampere. We heat this filament. Because of the heating, what comes out? Electron. So the same mechanism also occur in this cathode filament. So we have given milliampere current to the filament. So we call this filament current. This is called filament current. So the filament current heat the filament, and the electrons which are present at the surface, they comes out. This is the role of the current. Heating, we use the term therm. Thermo means heat. And what comes out? Electron. So the whole phenomena is called thermionic emission. Because of heating, electrons comes out. So this phenomena at the level of cathode is called thermionic emission. So the result of this thermionic emission, the result of this current, the result of heating this filament is your electrons. We call this electron as electron cloud. This is your cathode filament, and what we applied, milliampere. So current is applied, this current will heat the filament, and what comes out? Electron. These electrons, they will form a cloud at the filament itself. At this point of time, these electrons, they do not have the sufficient energy to move towards the anode. They do not have that kinetic energy, to move towards the anode. We just gave milliampere, hit the filament, what comes out? Electron cloud. From this point, this filament portion, in 2020 ICAR exam, they have asked one MCQ. And that MCQ was like this. This is your filament, and what we give, milliampere, it will heat it and electron will come out. The MCQ was, milliampere is related with the quantity of X-ray produced, quality of your X-ray produced. So the concept is very simple. More the milliampere you apply, okay, then more you will heat your filament. If we heat the filament, then more electron will come out. More the number of electron comes out, more will move toward the anode, and more will strike the anode, and that may lead to more number of X-rays. So this was the MCQ. That if we increase the MA, we heat the filament, more electrons comes out, more will move toward the anode, strike the anode, and what comes out? X-rays. So the milliampere is directly related to the quantity of X-ray produced. Not quality, it is quantity. Quality of X-ray produced is directly proportional to kVp. That we see after this topic. So milliampere is directly to heating of filament, more electrons, more will strike, more X-ray will be produced. So the milliampere is directly to quantity of X-ray produced. So at this point, what we did, this is your filament and this is your milliampere. We applied the milliampere. What comes out? Electron. This electron is a cloud. We need to focus them toward the anode. So to focus this cloud, we need something which is called a concave focusing cup. focusing cup that is made up of nickel or molybdenum. So the role of this focusing cup is to focus these electrons towards the anode, only to focus them, or you can say to prevent spread of cloud. This cloud, it is focused toward this side. So our X-ray tube, this is our X-ray tube, and this is cathode, and this is anode. The X-ray tube says, whatever you give to me, I will convert that part only. Suppose you give milliampere to me, I will give you electron written in your return. So from the outside, we have our machine, we increase or decrease, we can increase or decrease our MA. So we give the MA, this tube will say, I will give you electron. Then the tube says that I'm not going to move these electrons towards the anode. So the next demand of this tube is the tube want kVp. The tube want potential difference. The tube want voltage difference. This potential difference, this voltage difference, this is nothing but a kind of pulling force. The tube says, if you provide some voltage difference to me, I will give kinetic energy to these electrons, and I will move these electrons from this point to this. So if you give only Ma, then the tube will produce only electrons, and the things are stopped at this point of time. Then what we need to give is kVp, or potential difference, in between anode and your cathode. This energy, this kVp, if you give to the electron, then they will gain this energy and they will move toward the anode. So more the kVp, the electron will gain more energy. Because what this energy is, this is nothing but the kinetic energy. Because of kinetic energy, they are moving toward the anode. So more the kVp means we are giving more kinetic energy to the electron. They will move with that kinetic energy towards the anode. More the electron reaches here, more electron will strike at the target. More the number of electrons strike, then more X-rays will produced. But they are of high energy. Means kVp will give you kinetic energy. High energy electron moves toward the anode, and this energetic anode they strike and they produce high energy X-rays. And in radiology language, we call the high energy X-rays as quality. So if we are giving Ma, we increase the number of electrons. So Ma is related with the quantity. Your 2020 MCQ. The next thing is, these electrons are without any energy. If they have energy, that will be of no use, because we want such energy to move the electron towards the anode. They strike with that energy and brings out X-rays of different energy. So to give them energy, we give kVp. We give potential difference, voltage difference between these 2 points. So more the kVp, more the kinetic energy you give them, they will move with that energy, and that high energy will lead to generation of high energy X-rays. In radiology, for high energy X-rays, remember the term quality. So kVp is directly related to the quality. kVp is directly related to the energy of the X-ray produced. Again, this is your filament, and these are the electron cloud. They are simply sitting here. If you apply in between them kVp or potential difference, then they will move with kinetic energy. So high energy electron will strike and they will lead to high energy X-ray. Suppose there are 10 electrons. One electron is having 100 kilo electron volt energy, one is having 90 keV, one is having 75, one is having 65. The kVp what we gave, it was 100 kVp. So if you give 100 kVp to these electrons, some of them will having 100 kV energy, some will having 90, some 75, some 65. So with this energy, they all come to this target, they will strike and lead to generation of the X-ray. So the X-rays which will be generated, that will be of the same energy. Suppose one X-ray generated that is of 100 kilo electron volt energy. Next may be 90, next may be 75, 65. So the energy whatever we have given, that energy gained by the electron, and that energy again converted into the energy of the X-ray. So this is the concept. Okay, more energy. If your X-ray is of more energy, it will penetrate more. It will penetrate more. So if I summarize the two concepts, MA and KVP, in simple language, we can say MA directly to number of electrons and KVP is directly to energy of electron. That is nothing but energy of X-rays. Or more the energy means more the penetration power. So KVP is directly proportional to PP, penetration power. In case of radiology, the number of electron is called quantity, and energy of X-ray is called quality. So remember these 3 points. MA directly to number of electron or quantity. KVP is directly related to energy of the electron or directly to penetration power of the X-rays. So in this X-ray tube, we are done with two concepts. One is your MA, that is related with the concept of thermionic emission. You give the current that will hit the filament and what comes out? Electron cloud. Then the first duty is over. The X-ray tube says that if you give something called KVP, this electron will move to the anode and they will lead to production of your 1% X-ray. So we start giving KVP. Suppose 100 KVP is given. Out of that 100 KVP, some electron gain 100 keV, some gain 90 keV, and some 95, some 75. These all kinetically energetic electrons, they move, they strike, and they produce X-rays. And these X-rays will be, some may be of 100 keV, some may be 95, some may be 75 keV. So more the energy, more it will penetrate. So this KVP is directly to the penetration power. Suppose there is one thick, a obese and fatty dog, then to penetrate, suppose this is a very fatty dog and this is our X-ray tube and this is giving you the X-rays. So to penetrate this, the fatty body of this dog, we can increase KVP. More the KVP, more energetic electron will be produced, then more energetic will strike, more energetic X-rays will come out, and they will penetrate the fatty obese animal. So in case of a fatty bitch or obese, we can increase the KVP and we can penetrate the animal with our X-rays. Just opposite to that, if an animal is very weak because of weakness, the body is very thin. So what we can do, we can decrease the KVP. If you decrease the KVP, less energy X-ray will be produced, they will penetrate easily. And in case of obese, fatty, we can increase KVP, penetrate easily. This is the application of your KVP. So, one second. So we started our lecture with this line: X-rays are produced where high speed electrons strike metal. So in this concept, the metal was anode. Electron we can control by MA. Speed we can control by KVP, that is their motion, kinetic energy, and X-rays are 1% X-ray and 99% is your heat. So these four informations we can obtain from this line how X-rays are produced. How X-rays are produced, we give MA, electrons are generated. Then we give KVP, they will start moving. They will strike the anode, and what comes out? Your X-rays. So this is the meaning of this line. Next is when the electron strike anode, two mechanisms occur. Two mechanisms operate. One is collisional interaction. Another is non-collisional. There is no collision. Non-collisional, and it is also known as radiative interaction. This is called radiative interaction. So these are the two mechanisms which happen at the level of anode to produce the X-rays. So if they ask you in exam that out of these two mechanisms, which is the more important or which mechanism lead to maximum X-ray production, so your answer will be radiative interaction. Suppose we produce 100 X-rays. Out of 100, the 95 will be because of radiative interaction, and the 5 will be because of collision interaction. So in case of diagnostic radiology, the X-rays are produced mainly because of radiative interaction. So two types of MCQ, that in diagnostic radiology, X-rays are produced mainly by, answer will be radiative interaction. Second MCQ, in diagnostic radiology, X-rays are produced by, they are not talking about mainly, X-rays are produced by, so both collisional and this radiative. Because it is produced only 5 and it is 95, so the major portion is this, minor is this, but both are able to produce the X-rays. So where these two collisional or radiative mechanism are operating. This was our X-ray tube and this was the filament. What we gave Ma. What happens? Thermionic emission occurs. Okay. Then we applied KVP. They start moving and they reach at the anode. Anode is made up of tungsten atoms. So they say at the level of these atoms, two mechanisms occur. Two mechanisms operate. One is collision and one is radiative. At this level, two mechanisms operate: collisional interaction, radiative interaction. And this radiative will lead to 95 X-ray and this will lead to 5. So we'll start with this anode and we'll see what happens in collisional interaction and what happens in radiative interaction. So this is the moving electron beam strike at this. When it strikes at the anode, some interactions occur at this level. And these interactions, they are of two types, collisional and radiative. So we'll see what is collisional, what is radiative, why it is producing 5 and why this is producing 95. And then we'll see the total X-ray production from these two mechanisms which occur at this anode because of interaction of these electrons with these atoms. So the first mechanism is your collision. Collisional interaction means in this interaction there is collision. This is our filament. From the filament, what comes out? Electron with some kinetic energy, and they are coming at the anode. Anode is made up of atoms. Your tungsten atom, W equal to 74 atomic number. So if these are many atoms, if I bring one atom out, this one atom, and we start studying the interaction, this is the nucleus and these are the cells. So this electron, it is having high energy, it is fast moving electron. This electron will come and it will strike some inner shell electron. Because the name is collision, collision means it will hit. There will be collision. So this electron will come and hit this electron. Because of this hitting, because of this collision, this electron will come out. We say ejected electron. And what happens to this electron? This electron will also come out. In this collision, this electron loses most of its energy, but not all energy. So what comes out is this is of low energy. Why low energy? Because in this collision, it loses its most of the energy. So after collision, it comes out as a low energy electron. And this is the electron which was in the inner shell. So an atom with empty or hole or vacancy is not stable atom. To become stable, the electron from the outer shell, they will jump to inner shell. So during this jumping, they lose some energy. And that energy is your X-ray. So this is collisional interaction. Electron from the filament comes, collide with some inner shell electron that may kick out it comes out as ejected electron, and the electron itself which hits the electron, it will come out as a low energy because most of the energy is deposited here to eject that electron. So now there is a space. The atom with a space is always an unstable atom. So it want to make itself as a stable. So what it does, it the electron from outer shell they will move to the inner. During that transition, what comes out, it loses its energy in the form of X-ray. This is how X-ray are produced in collisional interaction. And these X-rays, the very important MCQ is these X-rays are characteristic X-rays. These are characteristic X-rays. The meaning of characteristic means they are characteristic of their atom from which they are coming out. They are characteristic of their shell from which they are coming out. So these X-rays are characteristic of their atom, their shell, or the binding energy from which they are coming out. So this is collisional interaction. And this collisional interaction may give you few X-rays, that is 5%. The another method or mechanism is your radiative interaction. Radiative interaction. In case of radiative interaction, there is no collision, there is no hit, and there is no ejection of electron. So remember the difference. There was a collision, that electron was hitting to some inner shell electron, and there was ejection of that electron. But all these three steps do not happen in radiative interaction. So what happens in radiative interaction? I will write the term attraction. Only attraction happens. Question is, why this attraction? The answer is, our tungsten atom having 74 atomic number. 74 atomic number means what? It is having 74 protons, 74 positive charges on its nucleus. So what is the significance of these 74 positive charges? In case of, this is the filament, again electron coming and it will strike at the anode. Anode is having atom. If I bring this atom out and look at the nucleus, this nucleus is having 74 positive charges. 74 positive charges. If I bring this electron towards this atom in case of radiative interaction, see, electron is having -1 charge and nucleus is having plus 74 charges. Look at the positivity of the nucleus. This huge positive charge, and this is very small negative, -1. So when the -1 comes near to plus 74, it will slow down, deaccelerate, it will slow down. It will be attracted, it will slow down. We use the term deaccelerate and we use the term brake. Brake means we apply brake. Who apply brake? This nucleus will apply brake. Because of applying brake, the -1, this small -1 charge will slow down, deaccelerate, brake, and when it comes near to the nucleus, so it will bend like this. During this attraction, during this interaction, it loses its energy in the form of X-ray. This is how the X-rays are produced in radiative interaction. We are having so much heavy, huge positive charges here, and what is coming inside this very small -1. When it comes near to the nucleus, it will attract, it will slow down this one, deaccelerate or apply some brake, and it will bend from its normal path, and it loses its energy in the form of X-ray. So this is how radiative interaction will lead to production of X-ray. in this interaction, if you compare this with the collisional, see, there is no collision with inner shell electron. Okay, no collision. Second, there is no ejection of electron, no ejection. And third, no hit with the electron. So no collision, no hit, no ejection. So what is there? Only attraction. Why attraction? Because it is having 74 positive charges, and this is -1. It will attract it easily, and all the energy will come out as X-ray. The difference between these two, collisional and radiative, is in case of collisional, we were getting some characteristic X-rays. But the radiative interaction, it will provide you, radiative will provide you a wide spectrum, a wide or broad spectrum of energy of X-rays. What does it mean? This is your atom, then having nucleus 74 positive charges. This is your electron. Suppose the electron moves like this. It will bend towards this. This electron is coming. It will bend and loses X-ray energy. One electron is coming little away from this, away from the nucleus. It will bend less and it will lose less energy. And this third electron is very far up from the nucleus. It will bend very less and it will lose very less energy. So in this way, we produce three types of X-ray. That is, X-ray 1 is highest energy, 2 is moderate energy, and X3, third X-ray, is of lowest energy. So in this way, as the electron is passing near or far with the nucleus, this is the nucleus, and if electron passes, it will bend at this point. If it is little away, it will bend less, it will bend less, and it will bend least. But in all the cases, it is losing energy, that is X-ray. It is also losing energy, X-ray. It is also losing, and this one. But the difference is these X-ray are of different energies. Why different energies? Because the electron which bend or slows down at this point because of this heavy attraction force will lose the maximum energy, and the which is very, this is at some distance, will lose some less energy. If you move little more away from nucleus, then further less energy. Further move distance, then least energy. So if I make a graph of these energies as versus the number of X-rays, this side we have number of X-rays. Y-axis we have number of X-rays, and this side we have X-rays energy. Suppose there are some X-rays of 5 kilo electron volt. Here 10, 20, 50, and 100. Then the graph will be like this. It means the number of X-rays which are having 5 keV are this much, and the number of X-rays which are having 10 kilo electron volt energy generated, they may lie at this place. Similarly, X-rays with this 90 energy, they will lie at this point, and some at this point, and 100 are very few in number. So this is a broad spectrum energy graph, which tells you that in case of radiative interactions, X-rays are produced, but they are of various energies, different energies. But we have studied one more thing, that was characteristic X-rays. So this broad spectrum will tell, so in case of diagnostic X-ray, two mechanisms are there. One is collision, one is radiative. That will produce 95 and suppose it is producing 5. So where these 5 lie in this graph? Okay, this is 95 continuous broad spectrum, various energies are there. And where are the 5? These characteristic peaks. Or I can make one peak here and one more peak here. So these 1, 2, 3, 4, these peaks are known as your characteristic X-rays. Characteristic X-rays. And these 4 peaks, they are produced because of collision. In case of diagnostic radiology, in case of this mechanism, this is a minor mechanism, it will produce less, but whatever it is produced, they are characteristic of the atom, they are characteristic of the shell. Characteristic of shell means in collision, the electron collide with the inner shell. Suppose electron collide with the K shell, then this is produced by the K shell. Suppose the electron collide with the L shell, then this X-ray is produced by L. This is by M. This is by N. So the characteristic radiations, they belong to one characteristic, one specific shell. That may be K, L, M, N. But all these KLMN activities, they are not present, they are not found in radiative interaction. Why? Because there is no collision. If you have collision, you are colliding with the K cell, L cell, then it will give you the characteristic KLMN cell X-rays. But in case of radiative, there is nothing like collision, no KLMN interaction. So what is there? Only attraction. The positive charges, 74 positive charges, they are attracting electrons. If the electron attracted very near, it will produce good energy. Very far, then it will produce less energy, X-rays. So one term I forgot to tell. In case of collision, we were getting characteristic X-rays. And in case of radiative, we are getting braking radiation. We call them braking radiation. Because of the brake, because of the slowdown, because of the deacceleration, we use the term braking radiation. In case of German language, braking is also called Bremsstrahlung radiation. So from this video, there are few MCQs derived. First is in diagnostic radiology, how many mechanisms are there? 2 mechanisms, collision, radiative. Collision will produce characteristic X-ray. Radiative will produce braking radiation. The another name is Bremsstrahlung radiation. Out of these two, which is a major one? Bremsstrahlung, the 95%. This is smaller one, collisional characteristic X-ray. Out of these two, which is having a broad spectrum energy X-rays, Bremsstrahlung, and which is having characteristic, that is your collisional, only one kind of energy. Then how to remember this? Collision, and one is your Bremsstrahlung. This C will tell you collision, that I am giving you characteristic X-ray. Characteristic. This B will help you to remind I am giving you broad spectrum X-rays. Means the meaning of both these terms is your graph. This graph, we are having some peaks, and continuous. So broad spectrum, that is this one, and characteristic means this peak. So these were 2 mechanisms in your X-ray production. Let me revise this in 1 minute. This is the filament. This is the filament. What you gave? MA. MA will heat the filament. What comes out? Electron. But these electrons will not move. So what we give? KVP. KVP, because of KVP, they will move and they will reach here. We are having atoms. So because of this, it reaches at this point. After reaching at this point, there will be two types of interaction. That may be collision. C for collision. C will produce C, characteristic X. And second is your Bremsstrahlung. B for B, it will produce broad spectrum X. So up to this we have covered these two parts. That MA will give you number of electrons, KVP will give energy, and once they are energized, they reach here. Two interactions occur. One is collision, one is Bremsstrahlung. This collision will produce characteristic X-ray, Brem will produce broad spectrum X-rays. And if you make one simple graph, then the graph will be like this. That is broad spectrum with some peaks. And these peaks are nothing but characteristic X-ray. So lot of MCQs in this portion. First MCQ, quantity with the MA, quality KVP. Next MCQ, measure mechanism, Brem.
So out of these, hello.
ऑडिबल सर जी, आवाज थोड़ी धीरे आ रही है, जोर से बोलो।
So these are two mechanisms: collisional, Bremsstrahlung, characteristic, and your broad spectrum. Then one small topic about the X-ray tube. The role of X-ray tube is to convert electrical energy into X-ray. So we have seen what are the source of X-rays, that is your filament, then electron, they striking, two mechanisms and producing the X-ray. What is the source of this electrical energy? In our home, suppose we are getting 60 Hertz and 120 volt. For an example only, 60 Hertz and 120 volt, this supply we are getting at our home. And this supply, if we give to the X-ray tube, then it will going to produce X-rays. Because the role of this tube is to convert electrical energy into your X-rays. So suppose there are 60 Hertz and 120 volt. So what is the meaning of this? 60 Hertz, and this is known as alternating current. So this is coming at our home, AC current at 60 Hertz frequency and suppose to 120 volt. 60 Hertz means there are, this is one cycle. 60 Hertz means in 1 second there are 60 cycles. There are 60 cycles like this. This is 1, then 2, 1, 2, 3, and like this. There are 60. If we, out of these 60 cycles, if we come to at one cycle means I can say 1/60th is a part of 60. So this one is a part of 60. So if one cycle means 1/60 second. This is important. If we look at this cycle, which is taking a time of 1/60 of 1 second, then at this point in this cycle, in this one cycle equal to 1/60th of a second. And if I bring this one cycle like this, it means If this AC current enter into my X-ray tube, then half of the time, 50% of time it will be positive and 50% of the time it is negative. So X-ray tube, if you give alternating current to my X-ray tube, it means this is cathode, this is anode. For the first time, this 50% or means this half of the time, the electron, they will go to the anode. Okay, in the half of 50% of the time, in this half cycle, electron go to the anode. But what happens in this another half cycle, this negative cycle? They will reverse back and they will come at the cathode and they will damage it. So an X-ray tube never uses alternating current. X-ray tube want something direct current, means the current which is in one direction. Because if you use this AC current, alternating current, which is having 50% of the time it is positive and 50% is negative, it means when the electron come for the first time, it will come at this. When the cycle again become reverse, it will reverse and will come to the cathode. And in this way, this electron will damage the cathode. So to prevent this damage, what we do, we convert this AC current into unidirectional current. In our X-ray tube, what we want, this is our filament and this is anode. We want electron to move in one direction only, not this direction. If you use this current, AC current, which is having plus and half, minus half. So this during the plus cycle, the electron will move towards the anode. Again, during negative half cycle, they will come back and damage our cathode. So how to convert this AC into one direction? That conversion is called rectification. We have something called generators. Inside the generator, we have rectifiers. We have rectifiers. This is our alternating current. We can we have two options. One is half wave rectifier. Another is full wave. Full wave rectifier. What does it mean? This is the cycle. One cycle. Half wave means this rectifier which is present in your generator, it will remove this half portion. And inside the X-ray tube will get only this half part. What is the meaning of this half part? This half part means from the filament to the anode only this half part will go and reach there. But this half part, we are losing this half part. Suppose we want to make our system more efficient, then we'll try to convert full wave rectification. Full wave rectification means what? This is positive. Okay, this is the positive. Instead of removing this half part, if we convert this half part like this, so in this way we are utilizing the full cycle by converting into one phase, and that will enter into the X-ray tube and electron move in one direction, that is filament to anode. So this is called rectification, where half wave is of no use, because in this way we are using something here. If you want to utilize the both part of our alternating current, then also convert this into some useful thing. So if we convert this, we are getting everything from filament to anode. So the X-ray tube will not work on AC current. If you forcefully give AC current, then the electron will first go to anode, then the anode then reverse back, they will damage your cathode. So the option left is rectification. So rectification means we convert it into only one direction so that electron can move only from filament to anode. Then there is one. What is the meaning of KVP? We have studied that KVP is the potential difference applying the pulling force and like this. What is the exact meaning of KVP? Alternating current coming at 60 Hz and 120 volt. If I say 80 kVp, 80 kilovolt. So what is the meaning of this 80 kilovolt? It means 80 kilovolt means this 120 volt, we increase the 120 volt to 80,000 volt. This is the meaning. 80 kVp. K means kilo. Kilo means 1000. So 80 means 80,000 volts. So this 120 volt current is increased by 80,000. Another example, 100 kVp. 100 kVp means we increase this volt current to 1 lakh times. 1 lakh volt increase to this much. Then what is the meaning of this 80,000 and 1 lakh? Increasing the volt to this much level. This is our filament and this is the anode. Applying 100 kVp in between cathode and anode means the potential difference, voltage difference between cathode and anode is 1 lakh volt. This is the meaning. 100 kVp means the potential difference between these two, the voltage difference between these two is how much volt? 1 lakh volt. 80 kVp means the potential difference between these two is 80,000 volt. So this much energy we give to the electron, they move towards, accelerated towards the anode. So if we are giving 100 kVp, this is the filament, they are the electrons, and this is our anode. And what comes out here? X-ray. Suppose we gave 100 kVp. 100 kVp is given to the electron. There is one, if I say that some ideal condition. Suppose 100 kVp was given and electron gain all the energy and it convert into their 100 kilo electron volt. The electron which gain all the energy 100, this will move and strike. It will produce X-ray and that is also 100. So what we gave 100 kVp, electron gain all the energy, strike and produce X-ray of the 100. In case of diagnostic radiology, this 100 to 100, this condition is rare, this is uncommon. That is very important. If you give 100 kVp, electron gain 100, strike, produce 100 kilo electron volt energy X-ray. This is rare. But it is there because there are some electrons, they gain 100%. But in majority of cases, if we look at the voltage, we are giving like this. If you give 100 at the peak, means at 100, it will remain for only an instant, very few milliseconds or less than that. So only one 2 or 3 electrons, they gain 100. But what about the other 97 electrons which are present at the filament level? These are the electrons. Out of this 100 kVp, some will gain 97, some will gain 95, some 90, and 75. And they will strike with the anode. Then what happens? Collisional or Bremsstrahlung interaction. Then what comes out? Your X-ray. Similarly, 97 will produce 97 energy X-ray, and this will 95, 90, and 75 kilo electron volt energy X-ray. So gain, suppose only one electron which gain 100 will strike, come produce 100. So this 100 is very less, rare, uncommon. But what is common is 90, 90, 80, 70, 60. Means variable energies gained by the electron from the kVp. They strike, Bremsstrahlung and collisional occur, X-ray produce, which may be of different energies. So in this way, we are done with all our mechanisms. We started with the Ma, which produced electron. Then we gave 100 kVp, which some gained 97, some 90, some 80, some 75. They moved towards the anode. Then collisional interaction, Bremsstrahlung interaction. Then what comes out? X-ray. Some X-rays 97, some 80, some 70, and very few 100. Different energies. And if we draw the graph that with the Morse energy spectrum like this, and with some peak. So what we have produced? We have produced X-ray beam. X-ray beam. Why we are calling it as a beam? So ending with this topic, this is our X-ray tube, and this is the small thin window. From this is the anode, and this is cathode, anode. From this window, what is coming out? This is coming out, and this complete is called X-ray beam. In this X-ray beam, some X-rays are having 100 kilo electron volt energy full, because they have gained full and produced full. But they are rare, only rare, 1 or 2. But majority are 97, 90, 80, 70, 30, 40. Out of these, the X-rays which are of low energy, like 30 and 20. Suppose these two are very low energy X-ray. Okay, these 30 and 20. We call them soft X-rays. They are of low energy, they are of no use. In diagnostic radiation, these low energy are of no use. So once this beam come out of the X-ray tube, then we apply here filter, aluminum filter. These filters will remove the 30, 20, 10 and 5 kilo electron volt energy X-ray. The X-rays which are having very low energy will remove at this level. That are your filters. So that the radiation which reach to our animal body, they must be able to penetrate. These low energy X-rays they are unable to penetrate, they just give exposure dose to the animal, which is of no use. So we want our X-ray beam should contain those X-rays which are of high energy. High energy means they will penetrate more and more penetrate and reach to the X-ray film and produce X-ray. With this concept, in 2020 ICAR exam, they have asked one MCQ, what are hard X-ray and what are soft X-ray? Hard X-ray, soft X-rays, this terminology is based on the penetration. Penetration. So out of this, in this beam, we have different energies X-ray. So can you think which one is your soft and which one is your hard? So 30 kilo electron volt energy X-rays, 20, 10, 5, 2, 1.5, all these are your soft X-rays. Why? Because they will come but they are unable to penetrate. What are hard X-rays? Those X-rays which are of high energy and they will penetrate. So based on this penetration, we call them some are as hard, some are as soft. This was your MCQ in 2020. And this hard and soft based on penetration, and the penetration in turn, it is based on the energy. Energy, more energetic X-rays, more they will penetrate. And more energetic, it is based on KVP. So the ultimate, what if you start the story will start at the KVP. More the KVP, more energetic strike, more energetic X-ray, more energy X-ray, more they penetrate. We call them hard X-ray. Yeah. And but in this bundle, we are getting some low energy. And we remove them, filter them with the aluminum filter, and what we are getting, or a beam with hard X-rays, a beam with high energetic X-ray. So not only filter, this is your X-ray tube. Okay, we have applied filter. It's okay that we have applied this filter. But this beam is divergent. This beam is divergent. Suppose this is your animal and this is the portion of thoracic cavity. Thoracic cavity. If I want to take X-ray of only thoracic cavity, but the beam is divergent, this beam causes unnecessary exposure to pelvic cavity, abdominal cavity, head, neck areas. But what we want, only thoracic cavity to be examined, to be radiographed. But this is a divergent beam. This is giving unnecessary exposure to the animal. So we have one option that we can convert a divergent beam into a directional beam. We can convert this divergent into directional. What we have collimator. The device is called collimator. What is the meaning of collimator? This is your divergent one. If I apply one collimator like this cone shape, suppose this is the cone shape collimator. This collimator, it will focus all the radiation to your target area. This is your thoracic cavity having lungs. So this is the filter. We removed all the low energy soft X-rays. Then the beam was divergent, giving unnecessary exposure to the pelvic, abdominal, head. We want to examine only the thoracic part. So this collimator makes the divergent into directional. So only this portion will get the X-rays, and you can examine your desired target X-rays of lungs. So this is the role of collimator, to make the divergent direction. And role of filter out the low energy food. So we stop our topic at this step. In the next video, we'll cover interaction of X-rays with animal body. Means this is the X-ray tube. In today's lecture, what we have seen, cathode, anode, and we have produced a divergent with the collimator, divergent X-ray beam. This much. Once it strike your animal body, some interactions occur with the animal. Once this directional beam strike this, what will happen? There may be photoelectric effect, there may be coherent effect, and there may be Compton effect. So this type of interaction of our beam with the animal will cover in the next.